So we're going to go over how to transform linear functions. So the first function we're going to start with is our parent function. Okay, in your parent functions, you'll be getting basic functions. So functions like y equals x or y equals x squared, those type of functions are called your parent functions because they're your beginning functions. Okay, so it's whatever your first function is, that's your parent function. And then if you do anything to that function, it's called a transformation, which means you're changing its position. You're moving it somehow on the graph. Okay, and there's 3 different types of transformations that we deal with in this class. We're going to deal with translations, which are when you move the graph up, down, left, or right. And we are only dealing with moving the graph up and down for this class. Okay, you'll do the rest of it some other class. So the translation moving it up would look something like y equals x minus 5 or y equals x plus 5. When you're adding or subtracting something to a graph, then it's a translation. Okay, so minusing would make it go down, adding would make it go up. That makes sense? All right, a rotation would look something like y equals 3x. When you're multiplying by a number, that's a rotation. Okay, it basically means you're taking your graph and you're twisting it somehow. So a positive number means you're rotating it counterclockwise. A negative number means you're rotating it clockwise. Okay, and then the last one, reflection is like a mirror image of the graph. So it's like you're flipping the graph, and you're always flipping the graph over your y-axis for this class, and it's like if you had a function like y equals negative 4x. If you're multiplying, if you're making it negative, it's a reflection. So do you have any questions on our types of transformations? No. Okay, so let's actually graph some then. So if I look at example 1 and given f of x equals x, so this is my parent function. So that's the one I'm going to graph first, and I'm given g of x equals x minus 5. And I'm going to use the points 1, 2, and 3. So if I plug those in then for x, and I end up with the same numbers, because we're not doing anything to that function. So y equals x always has the same numbers. So 1, 2, and 3 on my graph gives me a graph that looks like that. Okay, so if I'm just sketching the graph. Alright, if I look at g of x, where I'm taking x minus 5, if I use those same x values so that I'm consistent, 1 minus 5 gives me negative 4, 2 minus 5 gives me... Alright, so 1, negative 4, 2, negative 3, 3, negative 2. Okay, so I'm looking at what I need to do to get from my red graph to my green graph. And so what did I do on that case? Did I do a rotation, a reflection, or a translation? Translation, perfect. Okay, all I did was move it. Did I move it up or down? Okay. And how many units did I move it down? 5. Minus 5 tells me I'm moving it down 5, so I moved it down 5. So translation, down 5. Okay, so we're good on that one? Alright, if I look at example 2, and given the function f of x equals x plus 2, that's my parent function, because that's the first function I was given. So that's what I'm going to graph first. So if I do that and I use the same x values to be consistent, 1 plus 2 is 3, 2 plus 2 is 3 plus 2 is 5. Alright, so 1, 3, 2, 4, 3, 5. Okay, so that's going to be my first function. My second function is g of x, where I'm taking 2x plus 2. So times 2 plus 2. So 1 times 2 is 2 plus 2 is, okay, 2 times 2 is, plus 2 is, and 3 times 2 is 6 plus 2 is 8. Okay, so 1, 4, 2, 6, 3, 8. So I need to figure out what I need to do to get from my red graph to my green graph. So what did I do? Up to here, but I added 1 here and 2 there and 3 there, so it is a rotation. Very good. So for that one, it's a rotation because we took our original function and we multiplied it by 2. That's the only difference between x plus 2 and 2x plus 2 is that 2 up front. And so when you're multiplying by a number, then it's a rotation.
So these are all going to be graphs.
Alright, we'll do 2 more. So f of x equals 4x is my parent function. So if I use 1, 2, and 3, 4 times 1 is 4, 2 times 4 is 3 times 4 is 12. Okay, so for my first function, I'm at 1, 4, 2, 8, 3, 12. If I look at my second function, g of x equals negative 4x, 1 times negative 4 is negative 4, 2 times negative 4 is 3 times negative 4 is negative 12. So 1, down 4, down 8, down 12.
Here,
Perfect, so that's a reflection.
I'm really tired. I don't even know.
When you're flipping it, it's a reflection.
It's, yeah, looks exactly like.
Perfect, exactly. Okay, so that's what you guys are doing today. So work on 305, 1 through 19.